So here we understand what the encryption and decryption here means. So we will take an example of MD5 encryption and decryption here. So what is MD5? So MD5 or Message Digest 5 is a cryptographic function that allows you to create a 128-bit, that is 32 characters in hexadecimal, since you only need 4 ways to code hexadecimal hash from any input up to 2 into the power 64 bits. This produces a digital fingerprint of the file or text and thus allows to sign it for security verification. MD5 was created in 1991 as a replacement of MD4 algorithm. That, however, being a 128-bit algorithm too, suffered from security breaches. Collisions were found very early. That's why. So in 1996, actual collisions were also found on MD5, which is considered as insecure since then. Collisions were confirmed in 2004, like that. So despite being insecure, MD5 is still widely used as a file fingerprinting, such as SHA-1, which is another cryptographic functions we have, and password storage by webmaster that are not well informed by security. The hash produced by MD5 is supposed to be unique. It cannot be since 128-bit if even if the very large is finite. So for instance, if you type the word password with a capital, it will produce the following hash. As you can see, the password is now hashed into MD5, while the same word without the capital P gives this hash. See, these two hashes are different here. So how to decrypt MD5? Since MD5 is a hashing function, it is non-reversible, meaning that you cannot calculate the plain text that was hashed only looking at the hash. It's a one-way function. This is also why it is used to sign files and also store passwords. Thanks to this, webmasters are not in capacity to know your plain password from their databases. When you enter a password on the website, it is most of the time stored as hashes. Then, when you come back, this hash is compared to the hash of your password you enter. If they match the password were the same. So now, if MD5 is a one-way function, how do we decrypt it? We actually don't decrypt MD5. We use this word because it's easy to understand. But hashing function cannot be decrypted. It can be reversed. For this to happen, the only way to compare a given hash with the database of coupled password semicolon hash, like that. So this is what we have on the website. We have billions of hashes stored in our databases and more in our premium databases. When you enter a hash in your search bar, we'll look into your databases if we have a match. If we so, we provide you with the password. Now from premium search, you will have to buy credits. You can, but you can also enter hashes in your website search bar, or you're able to know if you have it or them in your premium databases. So you do not pay for nothing. Our database contains every dictionary that we're able to find on the internet. We also made our own dictionaries from statistical analysis of actual used password. We also brute force the unfound password very few weeks. If you if you if your hash wasn't found, you can come back later. Maybe we will have it cracked. If you're not able to crack it, you can still use paying brute force services such as hashes.com or online hashcrack.com. Or if you have a good GPU, you can download Hashcat and use it to crack MD5 hashes yourself. As stated before, MD5 isn't considered as secure since collisions were found in 1996, even though it's still widely used as webmasters. Plain MD5 is actually one of the worst an unsecure way to store passwords. Just plain text, of course. If you actually store MD5 on your databases and you don't want to record your password scheme to use better password hashing techniques, you can add a salt. The salt is a random string that will be added to the user's password. This will make online databases, rainbow tables and hash tables as ours useless because you would have to recalculate every password with the salt. So you could, for instance, rehash every password entered in your database by adding the salt to the user's password. For instance, if your MD5 password is the one we hashed before. So if you want to add a salt, for instance, a 128-bit salt, which is a minimum, it will look like this. If we add this salt to the user's MD5 on the database, it gives us this hash. Now we're encrypting it. So this is an example of how we add salt to it. So now it becomes like this. Now when an user wants to log on to your website, you just have to hash its password. Add your random salt to it, then rehash the concatenated string and check if it's the same MD5 you stored. You can also use a pepper, which is a database wide string that you add on top of the salted password. The better way though to store passwords nowadays is through flow hashing algorithm such as bcrypt or blowfish, which were created to slow down brute force technique as you can set the number of iteration. Also there's an automatic salt that is added to the password. How to create a strong password? As you can see on the website, password cracking has never been easier. With online databases and brute force using stronger and stronger GPUs. So how can you create a password that would be really strong and easy to remember? Because random strings are strong but very hard to remember, which means that you need a password manager. We advise users to create passphrases. A passphrase is easy to remember and its length makes it hard to break by plain brute force. A good word list with the right rules could break bad shaped passphrase. So when you create a passphrase, you should mix alphanumeric with special characters and don't shape the phrase like a real life phrase. Put some let's speak characters, for instance, double some letters, inverse some words, etc. For instance, a passphrase like would take centuries to be brute force even with the fastest GPU.